Hello, everybody, and welcome to this special video where we have pulled together a team of our experts here, actually, to look into one of the big sort of selling points of Veriff is our transparency. And what we want to talk about today is our transparency and how we fight document fraud. It's obviously something we see a lot of. We've pulled together our team of experts here to explain some of the tricks behind the scenes that you might see when we're sort of looking into this subject. So joining me today to do so is Paco Romero Ferrero, Javier Vargas, and Lisi German. Rather than me sort of introduce you, why don't we introduce ourselves? I'll go first. My name is Chris Hooper. I'm our content director here at Veriff. Lisi, would you like to go next, please?
Yes, hello, I'm Lisi, and I'm a product manager here in Veriff. So I'm trying to, in this case, try to understand what our customers need, what are the kind of fraud patterns we overall have, and then I have an amazing team, Javier and Paco, who help to make all this magic happen. So, Paco, do you want to talk next about you?
Hello. So welcome everyone. I'm Paco. I'm a data scientist working under Lisi at the verification automation team in Veriff. We work together at discovering signals from documents that are important for detecting fraud, and we build machine learning models for it. And I'll explain later some details of it. Javier, do you want to go next and say something about yourself?
Sure. Everybody, I'm Javier Vargas. I'm a senior machine learning research engineer, and I help to that by bringing the latest research into the table, exploring what is the current state of the art in the machine learning field, and try to apply that to solve our business problems.
Awesome. Thanks very much, guys. And I just want to say, too, that I absolutely love this team and the work that you guys do. It's incredible, the level of detail that you can go into. And I think we're going to sort of shine a light on some of that today, actually. I think, Lisi, why don't we start with you first? Could you just give us a kind of almost a top line description of what we're going to go through today? I know that we hear it all the time, and a lot of the research that we've done, certainly from a marketing point of view, looks into things like the rise of generative AI and deepfake fraud and even sort of Photoshop tools and things like that. One of the conclusions is that fraudsters are getting more and more sophisticated with the equipment they can use and the tactics that they can bring into play. How is it, in a very top line way, how does Veriff deal with that as a problem?
Yeah, so document fraud prevention is kind of core product. So whether you are buying any service or any ITV service from us, we are going to check what is in the document. Is this document legit or not? And I think what is the kind of, like you mentioned, Chris, the core thing we are providing to our customers is trust the decisions that we are doing are the right ones. And also we have tons of external knowledge about the documents. We have internal database of documents where we have all mapped down how different documents look like, what is the right document, what is the wrong documents. We are keeping eye on the different trends all the time. We have, for example, fraud operations team who is daily looking at some of the fraud trends. And yeah, the raise in fraudulent documents is there. We can see with different AI tools that there is way more easier to generate different kinds of fake documents. And also with now Gen AI able to do face images that really look like real people, it's also like having a boost in overall faking your identity. So what is our overall approach? Of course, is keeping eye on the trends. It is a little bit of cat and mouse game. We know that some things are changing, but also our core is to detect as much different elements on documents as we possibly can to make sure they are correct. And not only focusing on document elements, although we focus on this today, we are looking at broader picture. Does the user behavior look right? So we use so many different signals to understand that really the user that is coming in is really the who they say they are.
That's amazing. That's great to hear. And I think it's you're right to sort of point out that there is a much sort of bigger piece that goes on that we're talking about here. Where a lot of the tech that we use and everything else to confirm liveness and those types of things. But today we're just going to be focusing on the documents first and foremost.
Exactly.
And Paco, I think maybe over to you next, because you can probably run us through in a little bit more detail what actually that entails. And I think you've got some examples to show us as well.
Yeah, exactly. So we are going to go little by little showing more examples of what these signals are in the documents. But just using this sketch, you can see already that, for example, the border of this document is cut, is not straight. Also, these corners are not round as they are supposed to be. For example, we can see the driver license number wouldn't match the driver license number that we will extract from the barcode. We could also see that some fonts here are different to the rest of the fonts in the document. We could see perhaps that the signature here, it's a fake signature, it's a font. So these are some examples of some of the signals that we will look at in a document to, for example, say, okay, this document is fraudulent. We are not going to let this person pass. So just as a brief summary, this is what we will do. And later on, we will go into more detail.
That's awesome. I love that. And so I imagine sort of, fraudsters kind of change their strategies to sort of create more and more complex document fraud. I know that some of the examples you pointed out on this slide here, actually, I mean, they're sort of micro things, aren't they? But I think to sort of the fact that we have the ability to spot them is perhaps the most amazing thing for me, actually, and really what is sort of fundamental to the fraud performance as a whole, I think. I don't know if you want to sort of skip on to the next slide, because I think we want to talk about really how Veriff kind of keeps up to date, because as we mentioned at the beginning there, the landscape is ever changing, and I think the tools and the things that are available to fraudsters are sort of improving all of the time in their sophistication. So talk us a little bit through how Veriff is able to sort of stay ahead of the game here. And I think Lisa, you mentioned it's a bit of a game of cat and mouse in your sort of intro there. How do we do that? How do we play that game?
Exactly. That's one of the main challenges of detecting fraud, is that fraudsters are all the time imagining new ways of passing our systems, and we are all the time also trying to catch them, right? So, and the way we work is, and that's what we have found is the best solution, is to have a very tight collaboration between the fraud operation teams and the data science teams. And what this means is that the fraud operations are constantly monitoring the fraud trends in our traffic, coming from, like, as Lizzie said, not only documents, but the behavior and all the patterns of fraud that we can imagine. And then they annotate daily all the type of fraud cases for documents in this case. And this is annotated by specialists that are very well trained to detect small changes in the documents. And this will allow us to discover these new trends. And then they communicate these trends that they are finding with the data scientists. And we then work together on designing new ways of detecting these signals or handcrafting different features that the machine learning models will use. And then after we have designed these new signals that we are going to detect, we train models, and we train the models regularly. That's one of the keys as well. We train the models weekly or like monthly, depending on how the trends are coming. And that helps us catch fraud in a daily basis with a very high rate. And from our side, data scientists, we also have our monitoring of the AI model performance. So we are all the time checking that we don't have a decrease. This also helps a decrease in performance, sorry. And this also helps us notify fraud operation teams whether they should be looking at something in particular that they are not paying attention to. And overall, as a data scientist, we are also have research, machine learning research engineering in the team, like Javier that is with us, and later we'll explain some details. We are all the time looking at new state-of-the-art AI tools that can help us design better these features and these signals that help us catch fraud. I hope I gave you a good overall picture of how we work.
Yeah, absolutely. I think that's very thorough, and I think let's dive into some of that in a bit more detail, because I think that first of all, let's start with the signals that you mentioned, because I think they're sort of quite key to all of this, right? So let's elaborate on what they actually are and kind of some of the things you're looking for and what we can do with them.
Yeah. So before jumping in detail to the signals, let me tell you a bit more how we work, how this AI model that we have at Veriff works. We have documents that come into our system, like this would be the front and the back of a New York State identification card. And from this, we detect these signals that I'll explain later in some of them more in detail. And then we have a general artificial intelligence model that aggregates all this information, and using all the Veriff knowledge about how a legitimate document looks like, we train this model with around 1.5 million documents, so lots of data, and we train it frequently. And this allows us to catch the model. So this is how the machine learning model in a big picture works. So it's an aggregator of many fraudulent signals that we find in documents to detect the document fraud.
I see. Can you give us a bit more sort of background then as to sort of why you decided to go with that aggregator model? Because I think that's, I think the kind of the history of it is probably is going to be quite informative later on.
Yeah, we have experienced and tried black box models that just get a document and try to say whether it's fraudulent or not. But what we found is that by having all these signals very well fine-tuned and then aggregated together, the model that is generated after this allows, or it's capable of cross-linking and cross-matching all the different signals, and that gives a much better performance. In addition to that, by having all these signals separated and we know exactly where they come from, how they are computed, we can then query the model and ask, okay, what was the most important signal for this particular detection of fraud? Was it the background? Was it the shape of the document? What was it that made the model decide that that was fraudulent? And this level is transparent. This level of transparency is important because, in the one hand, it allows us to improve the model little by little by knowing which are the features that perform best or worst for the model, but also it allows us to inform our fraud operation teams of our specialists of what is the fraud that the model is finding and trying to find newer strategies of monitoring those cases.
One of the things I would add also for the benefit of doing all the signals separately is if we are finding those fraudulent documents, we a lot of the times use our internal operations to validate all of them. And if we can already point out like, hey, we think the document background is wrong, or that there is some font problems or date issues, then they already know where to focus on. Otherwise, they might also miss those signals. So we are a lot of the times helping out also our teams so that they know better what's going on.
Yeah. So it's a very interesting comment what Lizzie just made, because it's a very nice collaboration between artificial intelligence and humans, or like human teams that are looking at the documents day by day, because sometimes they discover something and sometimes the model discovers something that they maybe didn't catch or that slept their eyes, right? So it's a very nice way of working, and it's very fruitful.
Yeah, absolutely, and I love the sort of I think that sort of continuous learning piece is actually really important when we're talking about the evolution of fraud. It pays to be on the front foot and be sort of consistently kind of improving the way we do things internally as well. I can see you've got a list of some of the fraud signals on the slide here. I know this is not an exhaustive list, but could you run us through some of these and just explain a little more in detail, kind of the kind of things we'd be looking for and some of the things that crop up quite regularly?
Exactly. So this is just a sample of some of the signals that we look at, and I'm just going to briefly describe some of them. For example, two of them, that is the first ones we look at, is the document background and the document shape. This means like how the overall image of the document looks like and whether it looks similar to the documents that we know how they should look like, the same specimens. And we do that for the front and the back. And we also look at the shape of the document. We do look at the borders and try to find whether there's something in the borders that is suspicious for shape fraud, that we call it. Some other kinds of, we do something similar for portraits. We train models and we look at anomalies only for the portrait area of the documents, because we know that fraudsters like to either change the photos or create deepfakes for the photos, and sometimes they are very creative and it's very difficult to catch it, but we train particular models just to look at that region of the document. Similarly, we look at the font anomalies. So we extract all the characters in the document and we analyze the fonts, and we look whether there's anomalies in the shape, on the type font, on the size, on the spacing. So there's some of the different signals, for example. Something interesting as well regarding to characters that we extract is that sometimes fraudsters forget to remove some characters from the photos that they send that tell us that the document is actually not a legitimate one. For example, here the word specimen could tell us that, okay, this is not a real document. So we also look at that. This is very trivial, but surprisingly catches many cases. Some more interesting rules are hidden rules that we call it, that happen between the numbers of the documents and sometimes the date of birth or the date of issue. So there needs to be some relation between all the numbers that appear in the document that Veriff knows, because we have a huge database with all the information about the different specimens from different countries. So we use also that information. For example, similar to this information, we have the issue date in rate, so we can know whether a particular specimen, a particular serial number of specimens, of a specimen was issued in a given date range, and we can use that as another signal. Also, some specimens have barcodes or have MRZ zones where the information is duplicated in different parts of the document. So we are able to cross-reference all the information extracted to make sure that it matches and that there's nothing suspicious in or they didn't modify any of the fields. And finally, we also look at the signatures of the documents. And here, because we have recently developed some newer strategies to catch signature anomaly, I will pass the word to my colleague, Javier. If you have any doubts, I'll be happy to answer them, Chris.
That's awesome. Thank you. Now, that was a very thorough run through, and I think it's just a good snapshot into some of the tactics that we can use there. The signature anomalies is actually really interesting. Javier, welcome into this here too. I think it's it's obviously your sort of area of expertise where you've been working recently as well, but it feels to me like a very individual, a signature is a very individual sort of item, but in actual fact, you can tell a lot from it, I think. So why don't you tell us a little bit about it, some of the background there, and what it is that you've been working on here?
Yeah, actually, it is quite interesting. If you've heard what Paco said, we have this huge model that aggregates different signals from different models. So this would be just one model giving just one single signal. Because if you think about that, we have engineered this the same way that LLM are engineered, like ChatGPT and all other large language models. We have a lot of experts, like the model that take a look at the signature, the model that take a look at the portrait, the model that take a look at the font. And we aggregate all of that into one huge mixture of experts, which is the model that Paco is developing. And this is just an example to dig down on one of these single experts. But to give you a huge overview or a bird view of what we are developing here, Paco, how many signals, like flat signals, does our model take into account?
Yeah, like Carol, you're told, like right now we are in so like signals that we know exactly what they are. It's around like hundreds, and then like when we add other signals that are coming from more sophisticated models, we arrive at the thousands of signals that we can look at. So in total, it's like around 2,000 signals that we look at, and the model is aggregating together to decide what is fraudulent.
Exactly, that is quite interesting. So if you think about that, it's like having a human taking into account 2,000 signals for a single document each time a verification comes in. So that's mind-blowing. So if we look under the hood and we just ask one other model, hey, you are looking at the signatures. What are you looking there, right? Because AI is like a black box. Well, we actually do a lot of things with signature. Signature is something that has been used for verifying identity or for giving compliance to a document for a long time in history. And we have several measures to fight signature fraud. But today we are just gonna take a look into one, which is called signature blocklisting. Why is that? So this all starts because we notice a pattern. As Lizzie said before, we have our fraud specialist team, which is people highly trained on documents, and they start to see different fraud trends, and they tell us. And we saw that in our traffic, some signatures started to appear a lot of times in different documents in different parts of the globe. So we thought, hey, this is really strange, and we started to see that these signatures were actually fraud. So we thought, hey, let's build a solution around that. Let's try to isolate those kind of signatures. So every time that a signature like that comes in, we know it's fraud. So this is the solution we are going to dive in today. So if you can please click in. So one of the things that you could think is, how can an AI model tell if two signatures are the same? Because you take a signature and you have to compare with a signature that we know that is fraud. Well, for AI, that's not trivial. But we have a thing which is called embedding. Embedding, explained in plain English, is just an array of floating numbers. So this AI is capable of, you could say, compress an image signature into an array of strings. And then with that array, you can actually compute a smart operation between them. For example, computing the similarity. Computing the similarity between images in mathematical foundation could be as simple as computing the cosine similarity between those two vectors. So forget about the math. What we really need to know is that that operation gives an output 0, meaning the two signatures are quite different, and 1, meaning those signatures images are quite similar. So we can actually work with that. If you click, so how have we engineered this to work? So we have a pool of known fraud signatures. We took them, we know what they look like. So we generated a bank of embeddings, meaning an embedding per each signature. So every time a new signatures come into our traffic, we generate the embedding for this input signature. And then we compare it, the similarity, against all the signatures in our fraudulent bank. And we compute the similarity score of each one. And if the similarity is too high, then we say, hey, this signature is fake. Whereas if it is low, then we let it through. That's how it works mainly. But then you could think, okay, that's very nice. The model is giving you just an output, right? A number. How do you trust this model? Because Paco thought something very interesting before. Like in our mixture of expert model, we actually have transparency of what feature or signal was the most important to reach to a decision, and that's critical for our customers, because in the end we are in the business of trust. So how do we trust this experts model? Well, by looking at what they are doing under the hood. If we take those embeddings and we compute the principal component analysis, which is a standard operation in mathematical for vectors, we can see, and we plot them, we can see that for signatures that are fake, signatures that are similar, the principal component analysis is quite similar, which is the case on the left. Below, it's the signature we have in our block list, and above is the signature that comes in our traffic. So if you see this strange pattern of colors, that's what the PCA component look like. And if you see, these two signatures are quite similar, even though they are not specifically focused or specifically cropped. Whereas if you see on the right-hand side the legitimate signature, when a legitimate signature comes into our traffic, we compare it with our bank of fraudulent signatures, and we can see that the principal component analysis, it's quite dissimilar. You can actually see that, hey, the AI is focusing on the middle part because they both kind of have a middle part, but they lack the doodles on above and below. So the principal component analysis actually doesn't match. So that translates into a low similarity score. That means that we let the signature through our traffic. And that is kind of an overall view of how signature block listing work here at Veriff.
I love it. Thanks so much, Javier. That was very, very interesting. And I think it's worth pointing out a couple of things in there, actually. First of all, I think it's great that this comes from that sort of feedback loop we have internally as well, where you said that our internal experts had spotted this kind of stuff. We started to build a model around it, and it kind of grew from there. And now we have this incredible tool that we can use. And I think the second point to call out there, too, is that everything you've said there, you've described, happens very, very quickly as well. This isn't something that is, it takes minutes and minutes and minutes to do. It's literally seconds, and let's say the machine learning is very, very fast with this stuff and knows exactly what it's doing. So that's great. Lisi, maybe just a final thought from you. Obviously, this is an ongoing piece. This is kind of a snapshot in time. As of right now, this is where Veriff is. This is probably going to be very, very different in 6 months' time. What do you think is kind of on the horizon for the team here, and what would you sort of expect to see as we develop over the next few months from now?
Yeah, so definitely it's where we are today. And I think we have done a huge growth over the past year, I would say, on how we are approaching this problem. And like Paco mentioned, we have a little bit changed up that how data science and operations team are working and bringing them closer to get better results. But I think like what the future will hold is that we have solved maybe the biggest problems, but we still have definitely loopholes where we need to figure out how we can improve on those. So we are still continuing on using more and more embeddings. So that seems to be the trend today in the team on how we can use different embeddings and focus on different feature aspects. So maybe today we covered the signatures, but in the future we want to cover some other aspects on the documents. And maybe in the long term we will look more and more into also that if we can get everything already out of the image, how we can get the validation from the videos, from the registries. So I think this is the overall future where we are going. So today we are still fighting and are successful when the documents are document makers make mistakes. So we rely on it. But I think we also are looking in the future how we can make sure that we are always sure that the person that comes in through Veriff is the person they claim to be. And there are different ways we're thinking about for the future.
Sounds good to me. I like the sound of that. It means too that we can do another video in a few months' time, maybe, where we can have a latest news from you guys. So that's all we've got time for today, unfortunately. But Paco, Javier, Lisi, thank you ever so much for joining me, and thanks everybody for watching.